Let me show you what to do for the calculations for this, okay? We have these values here, and this is all we need. We don't need that, so let's just look at those values, right? So this is before, this is the half period before, okay? Is really just this number here minus this number, okay? And then the distance before is just going to be, well, I'll show you. There's a number of ways to do this, okay? But we're going to use these values here to find the radius before, okay? So before, okay, the half period is equal to 0.53 minus 0.00 or 0.53 seconds. That's easy, right? Okay, it was on this side, then it was on that side, right? Okay, and then the radius, we can find two radii, okay, by just subtracting these numbers. So R1 before is going to be 1.494 minus 0.317. So 1.494 minus 0.317 is okay, R2, these should be the same, by the way, okay, is going to be 2.621 minus 1.494. And this will give us some sense of how much I moved, right? So 2.621 minus 1.494. Is that right? 621, 2. Okay. It's 1.127. Okay. And then our uncertainty, so what we're going to use for the radius is, there's two ways to do it. You can either just go this minus this divided by 2, or you can average these two. I'm just going to go, our radius is 2.621 minus 0.317 divided by 2, right? That should be the same as this average, right? 2.621 minus 0.317 divided by 2. So, whoops. What did I do? Oh, I closed a parenthesis that I didn't open. Fine. Okay, let's see. That's 1.152. Okay, now if you average those other numbers, 1.177 plus 1.127 divided by 2, you get exactly the same thing, okay? So this is what we're going to use for the radius before, okay? And that's meters, okay? That's what we'll use. And then for our period, we're going to use that. And now if we want to figure out the velocity before, okay? Since it's a half period, right, that's just going to be pi times the radius over the half period, right? Okay, which is just, this is just 2 pi r over t. This is circumference divided by, or half circumference divided by half the period, right? Okay, so we're going to go pi times 1.152 divided by 0.53. Let's see if I can do that here. Pi times 1.152 divided by 0.53. 6.8. I'll just say 6.83. Okay. And that is our velocity. That's our best guess at our velocity. Okay. Now, we need to figure out what the uncertainty of this radius is. Okay, so what I'm going to do is I'm going to go this guy minus this guy divided by 2. Okay, or vice versa, right? Okay, so my uncertainty is plus or minus 1.177 minus 1.127 over 2. Let's figure that out, right? So 1.177 minus 1.127 divided by 2. Not too bad, 2.5 centimeters, right? So I'm getting that it's plus or minus 0.025 meters, okay? Did I do that right? Yeah, it looks like I did, okay? So now we've got the radius and the uncertainty of that. We're going to assume that this is plus or minus 1 frame of the video, right? Because that's the best resolution we can have. And technically what's going on here is that we're actually off by half a frame on either side. And since we measured twice, that gives us an uncertainty of 1/30th of a second, right? Of a second. Because I just use normal video. Now, if you're using slow-mo, you need to know how many frames a second is. If it's 60 frames a second, then your uncertainty will be 1/60th of a second, okay? So now we're going to figure out the uncertainty of our velocity before. So the uncertainty of that velocity is to 6.83. That's going to equal the uncertainty of our distance, so 0.025 over what we think the distance was, right? Plus 1/30th. A 30th is 0.0333, a lot of threes, right? Okay, divided by 0.53, right? And so we do the normal thing, right? We figure out this side, multiply it by 6.83, right? And our delta V is, let's figure this out. Okay, so I'm going to take that number. I'm going to take the raw number, the it's really 6.82851, whatever, right? So that guy times, left parenthesis, 0.025 divided by 1.15, whoops. Okay, plus 0.0333333, a bunch of threes, divided by 0.53, right parenthesis. Let's see what I get. And I get that this is plus or minus 0.58 roughly. Okay, so my velocity before is 6.83 meters per second plus or minus 0.58, okay? So now let's figure out the velocity afterwards, okay? Because we just don't know. Maybe the velocity afterwards might be more, but we might have an uncertainty that overlaps, right? So the Mandlbaur hypothesis could still be correct, right? So after, the half period is going to be 1.20. The half period is going to be 1.20, this guy minus this guy, minus 1.07, right? So 1.2 minus 1.07 is 0.13 seconds. So it definitely got, this period definitely got smaller, okay? So there's that, right? And this is plus or minus 1/30th of a second, okay? So now let's figure out the radii after, okay? So R1 is equal to 2.097 minus 1.573. So I'm doing this guy minus this guy, okay? That's a 3. Okay, so 2.097 minus 1.573, and that's 0.524 meters. Okay, and then let's find the other radius, right? And that's going to be this guy minus this guy, right? This guy minus this guy. So 1.573 minus 1.037. And that's 0, so 1.573 minus 1.037, and that is 0.536. And then the uncertainty, the average radius would just be the average of those, right? Or I can just go this minus this, right? The average is 2.097 minus 1.037 divided by 2. You can try averaging those and see if you get the same number as I get this way. Pretty sure they're the same. 2.097 minus 1.037 divided by 2. So on the average, it's R on the average is 0.53 meters, right? Now let's find the uncertainty of R, right? The uncertainty of R after is going to be 0.536 minus 0.524. So I'm using these guys here, right? I calculated 2 different radii, right? And I'm going to divide that by 2. So the delta R, the uncertainty of R afterwards is left parenthesis, this guy minus this guy divided by 2. 0.006. Wow, I held really still. That's crazy. Okay, 0.006 meters. I guess after I pulled it in, I just sat as still as I could, right? Okay, so this is plus or minus 0.006 meters. That's like less than a centimeter. I was like a statue. Although, you know, it's not much time too, right? I didn't move much. I didn't have time to move. Okay, wow. Okay, so now let's figure out the velocity and the uncertainty of the velocity afterwards, right? So V after is going to be pi times the radius after divided by the half period, right? Okay, so it's going to be pi. The period is 0.13, radius is 0.53. And the half period is 0.13 seconds. Wow, that's pretty fast. Okay. So let's do that. Pi times 0.53 divided by 0.13. 12.81 meters per second. Whoops. So it's definitely faster, right? Okay, but we don't know if it's faster by more than the uncertainty, right? That's what we're going for. So now we have to figure out the uncertainty, right? So the uncertainty, the delta V after, is going to be significantly more, right? Because the period's so small, right? So let's see, it's going to be, let's see, we got to go delta V divided by 12.81. So that's not equals, that's just, here's how we're doing it, right? Okay, it's going to be the uncertainty of the radius, so 0.006 over the radius of 0.53, is that right? Yeah. Plus a 30th of a second, so 0.0333, a bunch of threes, right? Divided by 0.13. See, that's a significant amount of this number here, right? Okay, so our uncertainty afterwards is going to be considerably more. So now I'm going to take that number I just got. I'm really just taking the raw number, which is 12.80803 or something like that, right? I'm going to go times the left parenthesis, 0.006 divided by 0.53 plus 0.033, a bunch of threes, divided by 0.13, right parenthesis, 3.43. So our delta V is 3.43 meters per second. So pretty significant, right? Uncertainty afterwards, right? So now we've got this guy is much lower than this guy, right? Okay. Notice that this is we cut the radius in half and we basically almost doubled the velocity, right? Okay, which is kind of what Newton's model predicts, right? But we still haven't disproven a Mandlbaur model yet, possibly, right? So what you want to do is you want to take this and subtract them, and the question is the disparity in those velocities, is that disparity bigger than the sum of these uncertainties? Okay, right? In other words, if you take this and add that, the smaller number, and add the uncertainty, and take the bigger number and subtract the uncertainty, can you make these overlap? I don't think you can, right? I think there's going to be a fairly significant gap between those. But anyway, that's the calculation that we want to see. Now, you can do that on pencil and paper if you want to. That's just fine. You can also just use the equation template that I put in the document that I gave you, whatever you like better. Okay, it might be easier to just do it on paper and take a picture of it, but I'll leave that up to you.